hear me? All these names. Yeah. So, hello, can you hear me now?
Yes.
Okay. Right. Right. All right. Okay, let's see. Let me take you to what we have this week. I mentioned in the class that you guys should print this chart, this procedure chart, and also this table. I also explained that we'll be using them now. So from now on, so I'm assuming that you have already printed them out. We'll be using them now until the end of the semester. I will take you to this page so you can see what you have for the week. Yeah. I think I opened it. I believe I opened it before. All right here. Okay. This is the classroom. And for my announcement, it's week 13. So the semester is almost over. This is what we have for the week. You have homework 7, which is due on the 20th. And that is the main thing we have. Yeah. So we are still on chapter 6, which is normal distribution. I know, remember, you can access all this by going to the models and then scroll down to the week which is here. I'm gonna put those to that table here so you can print it. I'll put it on. Let me add them now. So you can now download it at your convenience and print them out. Upload this table here. Statistical table. Please, can you mute yourself if you are doing something else? Then I'm gonna add a procedure chart. Please don't forget to print these 2 charts. Keep them handy.
I'm sorry, I just love my dates all over everything.
Please, can you mute yourself, ma'am?
Much.
Okay, we'll have. So I'm gonna add them here, so that after we finish, you can then print them out. I'm gonna add a statistical table here. It's right here. And I'm gonna add the procedure chart. So you can see that both of them are here. This is the statistical table. This is the procedure chart. Please print them out. We'll be using them now to the end of the semester. So having said that, we can now go to what you have today, which is normal distribution, a type of continuous probability distribution. So simply put, before I do that, let me close this. Close this part. So simply put, a normal distribution. Let me start this way. A lot of continuous variables such as height of men or women, temperature or cholesterol level of adults have distribution that are bell-shaped. When I say bell-shaped, I mean shaped like a bell. So this distribution, we call them normal distribution, bell-shaped distribution, or Gaussian distribution. Gaussian, based on the name of the German mathematician Carl Friedrich Gauss, who derived the equation. So some of those things, the variable that I mentioned, like if somebody is an adult, man or woman, there are certain height we expect an adult to have. There's a range. So then if most adults attain that height. Our temperature, there's a temperature we consider to be normal for a particular day. If it's below that temperature, it's not normal. That means you need to put the heater on, or if it's above that temperature, it's still not normal. That means you need to put the AC on. Even with AC or heater, there's still not the temperature that is considered normal. Above that is not normal, and below that is not normal. How about cholesterol level? That's what is considered to be normal. Every human being. So above that is not normal. Below that is also not normal. So again, we call them normal distribution. These distributions, and I mean, there are many examples. I'll give you. Let me come closer to home. In Maryland, most teachers, their annual income is between 50,000 to probably, depending on how many years of experience, 50 to 80,000 a year. Now, that is considered normal for Maryland. Now, if you see a Maryland full-time teacher making 30,000 a year, that's not normal. Or a Maryland teacher making $200,000 a year, that is also not normal. I mean, if that person becomes an complete outlier. So there are certain things we consider to be normal. So soil distribution, we call them normal distribution or bell-shaped distribution or Gaussian distribution. So this leads us to the short definition of the normal distribution. In plain terms, we can define a normal distribution as a continuous, symmetric, bell-shaped distribution of a variable. So now normal distribution can be used to describe a lot of variables for the simple reason that deviation from normal distribution are really small, not very little. So to some extent, not really, I'll say that, I won't use the word negligible, but the deviation are not really much. It's very small. Okay. So that we have the situation we have when it is too low below that normal range, we say that it's not normal. Now, when I say bell shape, you can see the bell shaped here, shaped like a bell. So you can see it goes from here, then peak at the middle, and then go down. So what is this range with the center line representing the mean? So, and with an asymptotic tail getting close to the x-axis, but never touches the x-axis. So you can see that this side, half of this is almost the same as half of this one. You can literally fold this into this. Now, I'll give you an example. Normal range for the systolic blood pressure is 110 to 140 millimeter of mercury. Okay. And the normal interval for a person's triglycerides is usually 30 to 200 milligram per deciliter. So anything above that is not normal, or anything below that is also not normal. How about the birth weight of a baby, a newborn baby, usually 6 to 9 pounds. So anything above that is overweight. And then below 2,700 pounds is underweight. So normal weight range is 2,700 pounds to 6 pounds to 9 pounds. Okay, 6 pounds to 9 pounds. So now, having said that, we can now look at some of the properties of the normal distribution. So the properties of normal distribution. First one is that a normal distribution is bell-shaped. That is shaped like a bell. I've already shown you the bell right here. Bell-shaped. Call it normal curve. The mean, median, and mode are equal and are located at the center of the distribution. You can see the mean, you can see right here, mean, median, mode, and they are located at the center of the distribution. The third formula property is that a normal distribution is unimodal. That means it has only one mode. You can see that you have only one peak. Yeah. Mode. The curve is symmetric about the mean. It's symmetric. That means what you have on the left side is the same as what you have on the right side. So it's the same. Like I said earlier, you can literally throw this part into this part. So it's symmetric. The curve is continuous, and that means that there's no gaps. Yep, it's continuous. See, goes no gap, smoothly, no gaps. Another one is that the curve never touches the x-axis. As you can see from my chart, it never touches the x-axis. Even though you get closer and closer to the x-axis, it never touches the x-axis. Then the total area under the normal curve, distribution curve, the total area under the normal distribution curve is equal to 1. So what does that mean? It means that this here is 0.5. Here is also 0.5. 0.5. Okay, which means that the total area will be 0.5 plus 0.5, which is 1.0 or 100%. Okay, so that's what it is saying, that the total area for both sides is 1 or 100%. Half of this is 0.5, half of this is 0.5. So having said that, does anybody have a question in what we have covered so far? Any question, guys? Okay, good. No question. Now, at this point, we are ready to do some work. It says, first question, the work will be done under the topic, calculating the areas under the standard normal curve. It says here, find the area under the standard normal curve, which lies to the left of Z 1.76. Okay. How do we do that? First thing is to draw the chart solution. Okay. Draw the chart. So we are talking about this one to the left of Z 1.76. So we're gonna put 1.760 here first. 1.76. Then we can draw the chart. Okay, if you have a question, you can ask me here. I'm not through chat room, but ask me here. I'm here now to answer your questions. Okay. Draw the charts.
Excuse me, Dr. Oji.
Yes, ma'am.
Should I message you about the makeup assignments?
We discussed the makeup when we finish the class. Okay.
Okay.
Right now, I want to question about what we are doing. Well,
okay.
Remember, I know this is the week we agreed. Right or wrong? Actually, it was last week, but I said I will start receiving it from you. I will start accepting it from you guys this week. Right or wrong?
Yes.
So I didn't forget. I keep my word. And just so long as you are qualified, you get the makeup. Yeah, this is something I take serious. When I have an agreement with my students, I honor my agreement. Okay. So now, the first thing is to draw the chart and put the center line. Okay. Now, so now you insert this the center line here. Give me a minute. Let me yep, right here. Put the center line. So when you're answering this question of the normal distribution, I expect you to see the chart. Put the chart in, okay? So that will be part of the credit. So if you don't put the chart in, you will have a partial credit, okay? So I want to draw the chart first to show me to explain the calculation you did. Now, next is to, now you have it says to the left of Z 1.76. So you got to put a line that represents 1.76. You can put that line right here. Okay. Then you say to the left of that. So that means you're going to shed the left side of it. You're going to shed the left side of it. So I'm going to shed from here to the left. Okay. To the left. Okay. Now, after you do that, you can now go to the procedure chart and see what chart, because it says here, find the area. So you're looking for the area. To find the area, after shedding the correct side, you go to the procedure chart to find it. Procedure chart will be this one here. Okay, it doesn't show here, but I'm going to show you what it is. Okay, when you go to the procedure chart, you make sure you choose the chart that has the exact shape as the one I just drew. I believe I opened too many pages, so I'm going to close some of the pages so we can have enough room for the other page where I have the chart drawn. Okay, let me see. This one, okay, and this one I'm going to close. Let me close some of this so I can have room for other. Okay, I'm going to close this one as well. So I have it now. Now I can see the chart. Okay. The procedure chart is right here. Yep. Now, we look at the procedure chart. There are many of them, about 5 of them, or 6 of them here. Now you look for the one that look exactly the way as the one I just drew. Look at the one I just drew. It's right here. And the one I drew. See, that's how it is shaded. This side, it didn't shed this side, only this left side was shaded. So you can see that the chart that looks exactly like that is this one here. This one. See, only the left side was shaded. And what did it tell us there? See, it says to the left of the Z value, where Z is greater than the mean, look up the Z value to get the area, add 0.5 to the area. Now, remember, there are 2 types of tables for normal distribution work. One is the one that you see on your homework. The other one is this one. This one is using normal. You can see the area under the standard normal distribution. This one is not cumulative. The one in your homework, you see your homework in MyLab+ is cumulative. Now I recommend that you use this one here, because this one here is based on the rules that I explained in this chart. So if you can't use this rule for the 1 year, that is that you will see in the MyLab+. So if you know how to use that particular table, fine. But don't use this rule if you are using the one in the MyLab+. That one is cumulative. So I recommend that you use this one for your assignments and tests. Follow this direction that the way I'm explaining it here for you. That way you will not have any problem. You still get the answer. Okay. So anyway, having said that, the chart that looks exactly like this one I drew is this one here. So look at the z-value to get the area at 0.528. Okay. Now let's take it to my diagram. So we're looking for the area for z 1.76. So first of all, we say at 0.5. So we're gonna put 0.5 plus. Now look for 1.76 on the table of normal distribution. 1.76. So I'm gonna look for 1.76 here. Okay. You can see you can see the z right here. You can see 1.7 right here. You gotta follow it all the way to under 6. And you can see that under 6 right here. You can see this under 6 right here. And the left is 1.7. It's 0.4608. Let me write it down. 0.4608. 0.4608. 4608. Okay. So we have found it. We can now go and put it in, and that will give us the answer we are looking for the area. 0.4608. And if you add them, you can verify this 0.9608. Any question to what I did? Okay, good. Excellent. Excellent. Now let's look at the second one example. It's the same 1.76, but this time around they say to the right of it. Okay. Again, we're looking for the area. So I'm gonna draw the chart first, as usual. We draw the chart first. We got 0, 1.76. Then you draw a chart. X-axis. Yeah, a little bit. Okay. Then put your bearer curve. You can put it from here. Okay. Okay. Bearer curve. You can put a center line. Center line. Then put line for 1.76 here. And they say to the right of it. This is the right side of it. So you're going to shade the right side of it. Okay. Yeah. Now, with this, next is to go to this procedure chart. So we're gonna go to the procedure chart to find a chart that looks exactly like this one. Whenever it's on this side, we say that it is at the tail. Yeah. So that it's at the tail side of the diagram. We say it's at the tail. Okay. We have that. we go to and look for the chart that looks like this one. Okay, in the procedure chart. Okay, you can see it right here. You can see this is the one that looks like that. It's the one right here. Make sure I've seen it. Yep, that's the one that looks like that. So the tail, see, in any tail, look at the z value to get the area, subtract the area from 0.5. Good. That's what you're going to do. And why are we subtracting from 0.5? Because the whole of half of this is 0.5. So if you're looking for only this portion, subtract the downside from here from 0.5. So you're going to do 0.5 minus, I'm looking for 1.76. We found 1.76 from the table. We did it before, but let me just, as a way of refreshing your memory, I'll put the table again. See, 1.7 right here. You go under 6. 0.4608. You see under 6, right? 0.4608. Okay. 0.4608. And we'll subtract, then you're gonna get, let's do this 0.5 minus that. You can get this on the calculator. Okay. 0.5 minus 0.4608. 0.0392. Okay. 0.0392. Good, and put it 0.0392. 0.0392. It's the area. Okay. Now, any question on this? Okay. No question. Excellent. Now, we can do the part 3. Okay. Part 3. Again, we have, as you say, between negative 0.87 and positive and z equals to 1.28. In that case, we now proceed as follows. Okay, we're looking for the area. The area is no, that the area is the same as the probability. Okay, don't forget that. Okay. Now we have two, one of them is a negative, one of them is positive. We can draw the charts to reflect that. Negative 0.87, 1.28. So with that, we're ready to draw our charts. Okay, we have this. Let's draw the chart, please. Okay. Then get to our bell curve. Okay. Bring this closer. Now we can now put the center line. Okay, now for this we have negative 0.87. I put the line for that. The line that represents that. Okay, we're gonna have it right here. I'll make it a little bit smaller so that we can accommodate that place. Make it 16. Okay, 16 for this one. Okay, 0.87. Then, of course, we have our center line, the 1.28. Okay, so for 1.28, we put the line for it. The line for 1.28. And it says the one area between them, that means the probability between them. So say between negative 8.8 or 0.87, not 8.8, 0.87 and 1.28. So that means between them means shared between them. Okay. So we're gonna share it. Okay. Okay. So now it's between the name. After doing that, you can now go to the procedure chart to see the one that looks exactly like that one. And that should be this one here. Okay? That should be this one here. Make sure I've seen this. Yep, guys, you got it. So I mean, it's number 4 is the one that looks like that. If you look at this and what I just drew, you will see that they look alike. They look alike. So what does the procedure table say we should do about that one? It's a look at the value to get the areas, then add the areas, which means that we'll find the areas for this, find the area for that. Or like I said, when I say area here, I mean the probability for the two of them. Then add the two probabilities. Now, let's look at this. This one is negative 0.87. Negative is just to tell you that it's on the left side. So on the table, you're not looking for negative. You're just looking for 0.87. So you go to 0.87. Okay. 0.87. Okay. I have it right here. You can see 0.8 here. You go under 7. See? Under 7.8. Under 7. All right, I'll give you 0.30, 0.3078. You go over there and put it in. Okay. 0.3078 plus. Now for this one, which is 1.28 here, you can look for it. 1.2 under 8. So 1.2 right here. You go under 8. 1.2 under 8. See right here. Okay. 0.3997. 1.2 under 8. 0.3997, write it down. Plus 0.3997. So you can write it there. .3997. And that will give you the answer. Okay? You got on the calculator 0.3078 plus 0.3997 give us 0.7075, and that becomes your answer for the area. So give you that 0.7075. Do you have any question on this, guys? Any question?
No question.
No.
All right, good, excellent. Now, there's another way I can ask this question. I can either ask you to find the area, or I can ask it in this form. See, this form says find the probabilities for each. So I can say find the probabilities for each using symbols. I can say P 0 less than Z less than 1.45. I mean, what this means that to find the probability between 0 and 1.45. This one says P 1.46 less than Z less than 2.97, which means find the probability between 1.46 to 2.97. That's what it means. They mean the same thing. So let's try maybe 2 here, because it is the same process as the one I just did. Only that is a matter of semantics, and put that way. So let's try part A. Maybe try another part here, another one here, and then you can follow that direction to do the rest. Otherwise, like I said, it's the same way. It's the same as the one we just did. I said that here they call it area, and they tell you to the left or to the right. Here they did the same thing, but they use symbols instead of words, and they use probabilities instead of area. So the first one I'm going to try this one here. Okay. Okay, find this. So what you're gonna do is, as usual, is to draw the chart 0 and 1.45. So let's draw the chart. I'm gonna put this so it doesn't too bold. Draw the chart. Get the for x-axis. Then for the bell curve, get this one. Yeah, and see that it's the same thing, except that then you put the center line. And it says between 0 and 1.45. 1.45 is right here on this the right side. Okay. Let me fix this. 1.45. See between that. So you can just draw the line. See between them. Just shed it. Okay. Now with that, you can find the area. Now we go to the procedure chart now. Okay. The procedure chart is right here. We'll find it from that side. This one. Excuse me. You look for that one that look the chart that look exactly like the one I have, and that is this one right here. This one. If you look at what I just drew, you see that there's a resemblance. So, like I said, you have to show the chart to prove your work. One of the ways to prove your work is to show the chart, draw the chart. Now, you can see that this. If you look at this and then look at what we have in the procedure chart, you see that they are the same. So here it says the required probability is to look up the z-value in the table to get the area. So for this, we look at what z-value. So we look for 1.45 on the table. Okay, 1.45. Okay, 1.4. In a minute. Okay, good. 1.4, you go under 5. 1.4 right here. You go under 5. Okay, see, under 5. 0.4265. 0.4265. Okay. 0.4265. You can put right there. 0.4265 is the answer we have. So depending on the shape of your bell curve, what you drew, and the area of the bell curve that you shaded, okay, that will decide if your answer is correct or not. Now, let's try another one. Let's try the one that have this one right here. Let's try this one. And then, of course, you can try the rest of them by yourself. It's really through the direction that the way I explain this here. This is part B. Well, actually, part E. We're looking for this probability. E. So we're looking for this probability at okay. Right here. You don't know what it is, so we're gonna again make a chart. Yeah. Make our chart. Okay, this time we have both of them are positive and they are on the same side. So I'm gonna have 0, 1.46 here, 2.97. So you can make the chart. Yeah, got it. Now I'm gonna extend this a little bit. Good, got it. Now I can bring a chart and I'm gonna got a chart. All right. So have it. I'm gonna make it a little bit so we can accommodate it. This is 14. Okay, I make some adjustment. You can now put the center line. Yeah. Let's move this a little bit. Yeah. Now, but two lines on the same side of the mains. This is the first one. And the second one is on the here. So now say between these two, we're gonna share the two between the two. So let us share it. Yeah. We have shared it. So now we can now look for a chart that looks like this one. So we go to the procedure table. So you can see that it is this one here. I look at that. This one. Say look at the z value to get the area, subtract the smaller area from the larger area. So we subtract the smaller area to the larger area. So let's go and do it. I have this. So let's find since we're subtracting the smaller area from the larger area, let's start with 2.97. Go to the table of normal distribution, start 2.97. Okay. 2.97. I'll be here. 2.97, 2.9 under 7. Okay, I think it's here. 7, 6. Okay. 2.9 under 7. 2.9 under 7. Yeah, 0.49. Hope you can see it. 0.4985. 0.4985. Okay. Let's get the other one, which is 1.46. 1.46. 1.46. So let's go and look for it. Okay, 1.4. You go under 6. 1, 2, 3, 4, 5. 0.4251. 0.4251. What it says here, 1.4, 1.46, yeah. 1.4 under 6. 1.4, you go under 6. Okay. 0.427, okay, because you see, come under 6 right here. So I have both of them, so I'm going to write them out. Say subtract from the other one. Okay. You subtract this. So you have the first one, we get this one as 0.49885. This is what you found on the table for it. And what we found for 2.97. Actually, this is what we found for 2.97. And for 1.46, we found 0.4251. So let's add them and get the final answer for that. So we have that what is it called? Okay, see. We can go to our calculator and use it to get the answer.
I'm good. Thank you. I love your hair as
Oh.
always.
Please, can you mute yourself? I mean, your phone, please. So you got 0.4985 minus 0.4251 is 0.0734. Now put it right there. Okay. 0.0734. So that is how you do it. Just follow the direction, draw the chart. You can do this rest of this as a practice on this. Let us move on to the next thing we have today. But before I do that, does anybody have a question on this?
No.
Okay, good. Now let's look at say finding specific z values for a given area. So in this case, we are doing the opposite of what we just did. Remember what we did here, they give us the z value and we find the area. But in this case, they give us the area and they want us to find the z value. How do we do that? So solution says find the z value so that the area under the normal distribution curve lies between 0 and 7, and the area is 0.2123. So let's say that the area is 0.2123. That's the area we are given. So we can can make a curve. Okay. Got 0. They didn't tell us what direction is z. So we can put it in any direction like we have. So so we can just put, let me put it here. But it can be in either way. Since they didn't say to the left or to the right. So now we can have our chart. Okay. Have this. Oh, I think I put the wrong thing. Have this. So I draw the line. And then put the bear curve. Yeah. Now we put the center line. So I'm gonna move it a little bit further. line that represents Z. Don't forget, it can be plus or minus. Okay, we'll have this. Yep. So I'm gonna extend this here. Now, it says Z value between 0. So value is say between 0 and Z. So I'm gonna between 0 and Z is right here. So we're gonna shade it between 0 and Z. Okay. Now it can be on the left side or on the right side, since they didn't tell us the direction, so that the Z now become Z. Z equals. You go to the table and look for this. Inside this time around, we're looking inside the table, not at the edges. So 212. Let me write this one down. 0.21 Z for 0.2123 will be equal to. So I'll take it to the table now. This is the table normal distribution. They look inside here. 0.2123. 2123 is right, guys. We don't have 2123. We have let's say 2123. Let's look for more. Right here. It's right here. 2123. And when you follow it to the left, you see it's 0.5. Go up, it's 0.6. So it's 0.56. So you have 0.56. Yeah. 0.56 right here now. So to the Z will be like I said, you follow it 2.2123. So you look inside the table we did, and we find that it's exactly the same way it's appeared. Then we follow it to the left, which is 0.5, and up 6 to get your first answer, to get your answer, basically to get a Z, 0.56. So what we got is 0.56 from the tables. 0.56. It's a Z. So that's how you just do the opposite. Let's try another example on that. It says that find the Z value to the left. See this one, they told you the direction to the left of the main. So that the area under the normal curve, so that the area under the normal distribution curve between 0 and the Z value is 0.3460. Again, of course, you need to draw a chart. So the area they give us is this 0.3460. You see to the left of it. Now we can make it the left of it. Okay, have area. Then we are looking for Z. Excuse me, Z equal. Now we can make our chart. I say to the left. Find the Z value to the left. So Z will be on the left side. Z. Got 0 here. And we can make our diagram. Okay, have it here. Then make you okay, I'm gonna wait this. Okay, good. Make your put your bell curve. Yeah. Now you put the center line. See Z point area for Z 0.34 3034. But you see that find the z-value to the left, which is on the left side. Let me put it on the left side, such that the area under the normal curve lies between 0 and 0.340. So yeah, that means you're talking about it between these two. Okay, let me see. So we see find the z-value to the left of the mean, so that the area under the normal distribution curve between 0 and z-value is okay, between 0 and 0. Okay, between 0 and z-value. Okay, it's between 0 and z-value, so that makes sense. So we can just this way, between 0 and the z-value. This is 0 and the z-value. Okay. Okay. Right. To the z. So let's go and look for this on the table. We go to the table. Before we go, let me write it down. Okay. So we have it as 0.3460. So that's what I'm looking for. Okay, I have it here. We'll open some of the there's some website. It's okay. Let me see if I can open that one. Okay. Well, actually, we have this. We have the number already, so we just need to look for it on the table. Let's go to and look for it. 0.23460. I've seen 3315 and 33340. 3315. Okay, which one is close to 3460? Okay, that's not the two, not the two. 3460. It can be these two, 3340, which is about 25 points away. This one, which is just 5 points. Oh, actually, 34. Not this one. We need 34. Oh, it's right here. 3461. So this is the closest to it. Follow the left, 1.0. Follow it up to 1.02. So you got 1.02. Let me go over there and put it 1.02. Yeah, but it's on the left side, so we got a negative 1.02. Now, anybody have question on what I just did for these two? Any questions? Okay. So then no question. Let's do the last one for the day before I can round up. This is this one. Oh, excuse me. What? 5. So find the z-value to the left. See, to the left, to the mean, such that 98.87% of the area under the normal distribution curve lies to the right of it. Now, this one is a tricky one, and I'll show you why as we proceed. But in the meantime, find the z-value to the left of the mean. So we have our chart first. Okay, the area give us this time around equals 98.87%, which is 0.987. Okay, now if we look at the table here, you will discover that the maximum number we have here, largest number we have here is 0.4999. So we don't have 0.888 group. Okay. So now since I didn't open, let me draw the chart first of all. Okay, let me draw the chart. So you can usually give us a picture of what we are doing. This should be on the left side. You see the 0? So I'm gonna put this line. Make sure what they're saying is. Yep, it's right here. So let's put the salary shapes. We have this. Here. Then put the bear curve. Bear curve. Yeah. Then put the center line. Okay. Okay. Anyway, they tell us that 98.87% of the area under the normal curve lies to the right of it. So you say z value to the left. So this is gonna be here. Okay. Z value to the left. This is the z right here. Z value to the left. Then that means here on the right, I think I'm gonna have my table pictures. But I'm gonna put this first so I can get my answer. Okay. Now I say that z value to the left, so that 98.87%. So you have, as a matter of fact, okay, 98.87% lies to the left of to the right of it. So that means you're shedding the whole of this area. See 98.8%, 98.87%, because z value is right here. So I'm gonna shed all that. Okay. Okay, have shed this whole place. Except all of them. Yep, shed it. Now you can now go to the procedure chart. Look for the one that's exactly that shape. We want to have exactly one shape. Okay. Now, like I say, you cannot see you cannot see 0.888 point half here 98.87% or 0.9887. That's what we have here, I believe, on this chart. Yeah, 9887. So, but knowing that you have this, what you're looking for is this only this side. Let me put it in a different way. When you have this, if you look at the chart, it says to look up the z value and then add it, because this is the one that looks like that right here. Because z value, then add 0.5 to it. Now, since we are doing the opposite, we're going to subtract 0.5 instead of adding to get a value that we can look for on the table. So which is, so this is minus 0.5. If you're using a cumulative table, you don't require to do this because to give you the wrong answer. Give us 0.4887. So instead of looking for 0.9887, look for 0.4887 on the table. Okay. Now, so that the z now becomes, because it's on the left side, you got a negative, look for 0.4887 on the table. Okay, 0.4887 should be okay. Let's see, it's actually on the table. What is my table? Oh, it's gonna be here. 0.4887. Okay. Let's see. Right. See right here. You're lucky. You find the exact number, 0.4887, and then follow it to the left. 2.2. See, follow it all the way to the left. Yeah, hopefully it's right. It's 4.61. Okay. So if you flow it all the way to the left, see that it's 2.2, and it comes under 8. So again, it's 2.2, 2.2, and it comes under 8. So 2.28. So answer will be 2.28. But it will be negative because it's on the left side. 2.28. Okay. Any question for me, guys, on this? Any question? Okay. Now, on Thursday, we'll begin from the standard normal distribution from here. Now, some of you say that you want to ask question about the makeup. Hello, you there?
Yes.
Yeah, somebody said before that they want to ask question about the makeup. Can ask now.
Okay, so since I'm eligible,
Yeah,
how many assignments?
if
Like
you
which
are
one?
if you are if your attendance score is 70% or more, yes, you can send me email today. List the 5 assignments. It might be a homework, it might be a classwork, it might be a test. Okay. Now you have to list the names. So if I see your email, you have my email. My email is on the syllabus. If you have
Yes.
you send me the email, I look at your grade. If it's 70% or more, by Friday, I'll send you the equations that you will solve to make up those assignments that you choose. Okay?
Can you repeat what you just said, please?
Let's say that you want to make up 5 assignments. Oh, well, 5. I can't go beyond 5.
Uh-huh.
So the 5 assignments, it can be a homework. Some of them can be homework. Some of them can be classwork. Some can be Excel assignments, or it can be test. So, but it cannot be more than 5. So if your attendance is if your attendance score on the grade book is 70% or more, then you can send me the email today or tomorrow. Then when I check it, and if it's good, if you are good with the attendance, then I'll send you the question. Now, if your attendance score is not up to 70, it's not 70%, then you can't send me. I will not approve it. So what you're gonna do is you're gonna continue to show up for class. Once the attendance goes up, let's say by the end of the month, then you can make your own request. Okay? I believe that answered your question. Any other?
I have a question.
Yes,
ma'am.
you answered my question. Thank
Oh, my
you.
bad.
Yeah.
Sorry, Professor. I know you said at the end of the year we'll be able to redo assignments we missed. So when are you gonna make that available?
I just said it now.
Oh, my bad. I didn't hear you. Can you repeat it?
If your attendance score is 70% or more,
Uh-huh.
you can send me email today or tomorrow with the list of the assignments. Each assignment in this class has a name.
Okay.
Class of 1, test 1, homework. It cannot go beyond 5.
Okay, and another question is, I think that's a day we didn't have class. You dropped my attendance.
No, I didn't. If you don't have a class, I don't put attendance.
I don't know. It said you dropped it. I had an 81 and now it's a 78. But
Well, I updated attendance from the beginning of this semester to last week, to where we are last week. So
okay.
that's
So
why
I was in class last week, so I just was confused as to why my
last week
degree dropped.
wasn't on top.
No, we had class on Tuesday, but
We have a
Thursday I
class on
don't think we
Tuesday.
had
Then
class, but my grade
when it is
dropped.
on Thursday, we didn't. So I didn't put any attendance on Thursday. I put on Tuesday.
Okay.
All right.
Thank you.
Welcome. So I see you guys on Thursday, okay? So if you send me the email by Friday, if I check your grade book and your attendance is up to 70% or more, then I will send you the questions for the makeup. Yeah. All right. Have a nice day, guys.